Welcome to this very quick tutorial on how to use the code for quantifying the similarity of paleomagnetic poles. Now, I'm assuming that you've made it this far onto the website that contains the code, and then simply if we click on the link, you'll get some information here about different ways in which you can run the code. The easiest way to do it is on the cloud. There's an interactive Jupyter notebook available, and you launch the cloud version just by clicking on the button here. This will automatically take you to Binder, which is a free cloud service, and it will start loading up an instance of the Jupyter Notebook for processing. Now, this is all held on the Binder server. It's not downloading anything onto your computer. And if you want to view the progress of what's happening, you can click on the Show button here, and you'll see that it's giving you some launch information, and now it's launched this version of the Jupyter Hub server on the cloud. So the notebook that we need to use, you'll see there's a number of files here, but the one that we're interested in is the IPython notebook. It's actually a Jupyter notebook, so we just click on this one to launch it. There's a number of amount of text at the top that just explains the version, the associated paper, the tutorial video, and so on. And as you move downwards, you'll see information that's needed to execute the code and the kind of the parameters that need to be entered in order to make the calculations that we present in the paper. So even if you've never used Jupyter or Python before, this is no problem, because once we run the first piece of code, it's just going to open up an interactive interface where you can enter the information. The key bits of information you need to compare your poles, we call them pole P and pole Q. Each is defined by 4 parameters. These are the standard parameters that we use for characterizing a pole, specifically the pole latitude in degrees, the pole longitude in degrees, the precision or the Fisher distribution dispersion of the pole, the kappa value, and the R value, which is the resultant length of the mean vector from which the pole was estimated. So if you've estimated kappa, you'll have had to first find R in order to estimate kappa. So these are 4 standard parameters that characterize your pole. So in order to launch the interface, we just go and we click on the code cell here. You can see it's highlighted in green, and then we press Shift and Enter together. This will launch the interface. If I just scroll downwards, you can see I can put in values for defining pole P in terms of a latitude, longitude, kappa, and R. Pole Q in terms, again, latitude, longitude, kappa, and R. And I can just change these values, and then the metrics representing the similarity of the poles that are presented in the paper, these values will be automatically updated as you change the values. So just as an example, if I change this kappa from 0.01 to 10 and press enter, you can see it's automatically updated the values here. So you can just enter your appropriate pole information. Make sure you hit enter after you change each value. So for example, if I change this to 45, I need to press enter in order for the parameters to update. And then ultimately, with using this interactive interface, you'll get the values for the 2 metrics. I'm not going to explain those metrics in details here because they're explained in the paper, but that's the full extent of the software. You simply need to enter your pole characterizations in the 2 areas here, and the values of the coefficient and the Bayes error will automatically update themselves.